What's up, everyone? In this episode of Console, we're going to be looking at Alex, which is a Microsoft research repository. It was actually a research paper, but they open sourced the code. And this project is basically a B plus tree where they've put linear regression inside each of the nodes of the B plus tree. So it's a bit of a mixture between a tree and machine learning, I guess. And it's my understanding the main intent of this project is to be used in like databases and things like that, right? So if you're familiar with databases in any way, you're aware that most of the indexing in the database is done by some sort of tree structure, and typically it's a B plus tree. And so what they've done, which I think is very interesting, is they've kind of introduced linear regression into the mix in order to kind of statistically predict which node you should be going to next in the B plus tree, basically. So super interesting stuff. We're going to basically pull the repo down, we're going to play around with it, and we're going to see what we can learn from it. So yeah, it was research, Microsoft Research, who kind of I would imagine funded this project. Most of the commits, when I was poking around, are done by a MIT PhD, which I'll link to his LinkedIn in the description of the video. So without further ado, let's just jump right in. So this is the repository we'll be looking at today. I'll be sure to link to it in the description. It's got a README, so we'll kind of be following along with the README. They mention here that you need C++ 14. Later in the video, I'll go through and get CMake working because they provide you a build script which uses CMake. Right now, I'm just taking care of a little bit of bookkeeping. As you've seen in previous console episodes, I like to keep all the code in separate directories, so I'm doing that here. But the first thing we'll do is kind of like make sure that my C++ all works because most of the code in this repository is C++ code, which makes sense. As I mentioned in the introduction to the video, this is intended to be used in a database, so you want to squeeze all the performance you can out of the programming language. So you can see right here, I'm basically just writing a basic C++. I want to make sure that I have C++ 14 on here before I move any further, and turns out I do. So the compilation worked, right? But I didn't have any C++ 14 syntax in that code. Like, the flag got accepted fine in GCC, but it could be that maybe it was like an ignored flag or something like that. So what I'm doing here is I'm just looking up keywords and seeing if there's a specific C++ keyword I can throw in the code and make sure that the compiler can accept it, kind of proving to myself that C++ 14 is working here. And so I add auto here and it ends up working. So we're all clear on that front. So once we get back to the repo, now that we know C++ 14 is working fine, it turns out they actually provide you with like an example program. So one of the things I was going to do when I opened this repo initially was I was going to like, the idea of this project is that you'll have basically a hash map kind of an interface in C++, but behind the scenes there will be this like linear regression model that you're building in each of the nodes of the hash map. So what I was thinking is like, okay, I'll pull this code down and write my own, or play around with this hash map basically. But it turns out they provide you an example. So I was like, oh, okay, we'll just clone the repo and play around with their existing example and kind of see how it behaves and all that stuff. So I'm following their instructions right here though, running their build script, but you can see there's a CMake command here, right? And it turns out I don't have CMake on this particular user, and so I have to go on like a side quest, if you will, and get CMake running. Okay, we're back, and this time we have CMake running. So I'm just running their build script. You could see I catted it in the previous section of this video. It takes a little while because it's like the initial build here, and so while this is building up all the code, I go back to the repo and just kind of play around with it. They talk about a bunch of benchmarking and various things like that. So here I am, like poking around with the code while I'm waiting for the build to finish, the initial build to finish. As I said, at this point, I was like, okay, I'm going to try and like make my own hash map and do all this stuff. But you can see that in the example, they're showing you that already. So there wasn't much else I had to do after I had built the code. So right here is where they're talking about the benchmarking, and then like if you want to see the true power of Alex, go download this data set from Google Drive, and then you can really run it through the gamut using the command they show just above there. So I'm like, okay, let's try that. I download the data. It's about, I think it was 1.5 gigs or something like that. Yeah, 1.5. And you'll see later in the video where we play around with this. There was a couple problems I ran into when I was trying to run the benchmark. Like there's a bulk load method that they provide on top of the hash map, and it wasn't working. Like it would just hang with the commands that they provide in the repo. So I had to do a little bit of playing around with that. We'll see that later. Okay, so the build's finished at this point, and then you can see here that I'm running the example script. So since I didn't see any errors spit out by the example script, I know, okay, everything's working fine, my build completed, and indeed the hash map is behaving as they say it does in that example.cpp. I also run the unit tests just to make sure as well, but then I'm like, okay, I've done enough playing around, like everything's set up at this point, let's take this thing through a test drive like they're kind of suggesting. So I take their command from the repo and I hit go, and it reads my flags as expected, and nothing happens. And so I switch to Htop. I go, oh, let's see if the Mac is actually doing something, right? If there's CPU being used or memory being used or whatever. Well, it turns out I don't have Htop. So I tried Top. I don't have Top either. So I'm like, okay, let me go install Htop and revisit this command after I can kind of see whether or not the Mac is doing something. Okay, we're back and we have Htop. You could see that there's some like memory usage or some CPU usage. That top command, right, that's using like 81%, 88% is actually the load tests provided by Alex. When I go back to that, you'll see that there's no output though, right? It's just sitting there, but it's clearly doing something, right? CPU's going up, it's going down, it's using the most amount of the CPU. Memory's not changing though, which is kind of surprising because it's a bulk load command that's being run at this point. So I'm like, you would expect the memory to increase for that particular process. You can see, right, there's nothing going on here. So for whatever reason, I didn't have time to go investigate why that is, but the bulk load was just hanging, wasn't doing anything. So while that bulk load is doing absolutely nothing, I go back to the repo and kind of poke through, read through what's in the README. They mention like the inspiration, I guess, for Alex is this learned IndEX paper, right? So I'm kind of poking through that. I don't go through read the research paper. I also don't read the Alex research paper either. If there's interest, we can certainly do that. I can go through, read that, and kind of explain the internal details. But the code is open source, right? So if you want to go see, I would prefer to read code in most cases than like a research paper about the code, right? Because the code is much more true to what's actually happening at the engineering level. So I'm glad they open source this, and kind of prefer that research be open source rather than like reading a research paper. That said, when we do the benchmarking, when I finally get the benchmarking thing working, we'll see some, in my opinion, surprising results. And I would imagine if I read the research paper, I either A, wouldn't be surprised, or I would B, be able to see what data they were producing when they ran the benchmark tests. And that would tell me, whether this repo is doing something unexpected or if I'm just like misinterpreting the data that I'm getting back from this load test. So they actually have API documentation in the repo, so I'm just pointing that out to you here so you can go check it out yourself, right? So if you did actually want to pull down this code and use it yourself, again, it's research and it's relatively experimental, so I wouldn't suggest using it in production. It's also supposed to be used in a database, right, for the most part, so I wouldn't recommend you do that, but if you want, the API is here. You can pull down the repo yourself and actually make this work. So at this point, my benchmark is still hanging. I've let it run for probably way too long. And I'm realizing, okay, something is not right here. How do I fix this? Luckily, I've pulled down the code, right? But you can see here I'm like kind of perusing it, going, what is this thing supposed to do, right? Because at this point, All I've done is just, they've told me to run this command and I've like, okay, I'll run it, and it's not working. So right at this point I have to go look in the code, see kind of what's going on. What I like to do is just put print statements all over and see where is this actually hanging, because I have no idea. So that was one of the things that kind of annoyed me about this, was like, if you're going to provide example code or benchmarking code, like there's no reason not to put print statements all over the place. They have a couple here and there throughout the code, but like the more the better. I don't see anything wrong with like explaining every single step of the code as you're running things, right? Particularly in examples and in benchmarking code. Maybe you don't need to do that in the actual implementation of the code, but you should certainly do that, especially if you're going to open source the code here. So that was one thing that annoyed me. Just wanted to call it out here, that I had to go in and write a bunch of my own print statements in order to see what was going on. So after adding a bunch of print statements all over the code and rerunning the command, you can see that it's stuck here in performing bulk load, which I still wasn't even sure, like, okay, maybe it's just a lot of data and that's what's causing the problem. And it very well could be that, if I left this running for 2 hours, eventually the bulk load would succeed. But that's not written anywhere in the repo or in any comments or anything like that, right? So you're kind of just like grasping at straws, trying to figure out what exactly is going on, especially given this is like experimental, right? It's even harder to figure out like what exactly am I supposed to be doing, particularly with no print statements. So after poking around with the code, I decide the init num keys is the problem here with the bulk loading. And indeed, after I reduce that number down, you can see that it's actually running one of the batches. So basically the way the load test works is it does a bunch of inserts and a bunch of reads based on like the parameters you pass in, and then times itself while it's doing those in order for you to like benchmark and see how fast is this thing supposed to be performing. One thing I wish they would have done is like maybe benchmark this against, I think they mentioned some sort of B+ tree implementation in the standard library of C or something like that. I kind of wish they would have done that, like, because the numbers don't mean anything, right? When you're running the benchmark, you're just going, oh, great, I guess 2 operations per second is good. I don't know, right? I have no frame of reference for like how should this actually be performing, and is it in fact performing better than the way they are suggesting that it does in the README. So here's another problem, right, is that it only runs 2 batches, and I'm like, why is that? I can't tell if it's timing out or if it's like hitting the max number of operations that I had defined in the flag, because there's no print statements as those are running either. You don't know how many operations you've ran. I mean, you could do the math, of course, right? So I put a couple print statements for both of these 2 break cases in order to see which one is actually being triggered. It turns out that it was timing out, so I bumped the timeout time. And so now we're finally getting somewhere, right? We're actually running all these batches, but this is what I was saying before, where I'm getting a little confused by what I'm expected to see here, because I would have guessed as the linear regression in the nodes was getting smarter or more accurate, that the number of operations would be going up, the number of operations per second, right? And you can see the cumulative throughput for each of these runs is actually going down. So it seems like the tree is getting less and less efficient as time goes on, which, as I said, was kind of confusing to me. I wouldn't have expected that, but I didn't read the research paper, so maybe this is expected. Again, if there's interest in like more of this stuff, then I would probably be more than happy to check out that research paper and kind of explain what's going on here. But as it stands now, consider me confused. So while I'm letting those run, because I'm thinking, oh, maybe it will get better over time as the load tests run, I figure like let's go try and figure out what's going on with that bulk load problem, right, where it was just hanging. So I kind of start perusing the actual source code of the tree here. I also kind of want to see like how are they doing the modeling and like what's actually going on in the source code to build this tree and all the other stuff. So this is actually the source code to like instantiate the tree at the very beginning with just a bunch of values, what they're calling the bulk load, quote unquote. And you can see that there's like this linear model object and it's going to calculate a CDF, and based on the CDF return for that node, right, you're going to choose which child you need to go to get that value. So it is indeed doing what they're suggesting. They're training a bit of a model at each node inside of the tree, and then going down the tree based on like the values returned for the model. I definitely recommend checking out the source code. It's really interesting code. Also, this is like when I start going, oh, who wrote this code, right? Like often as a developer, you just like, oh, this is great. I just have to pull down this library, and you don't ever stop and go, who wrote this? That's part of the reason why I'm doing these series of videos. So this is where I go find the MIT PhD student who did the majority of the code here. Right here. So kudos to Jilin Ding. As I said in the introduction, I'll definitely be leaving links all over, so you can contact Jilin if you have any questions or maybe work for Jilin. That's everything for this episode of Console. Don't forget to like and subscribe and click that little bell. That way you're notified every time a new episode comes out, and they do come out weekly. So if you didn't like this episode, I guarantee you'll like the next one, or maybe one of the previous ones. This project was super interesting. It's a super interesting concept. Again, it was pretty experimental. I ran into a bunch of problems, like just running the load tests, and I was able to like trigger seg faults and all sorts of things in the code. That said, it is research, right? So the intent is not necessarily to put this into production, but more to like give a more concrete understanding of what was in the research paper itself, right? So eventually someone else will productionize that, but we have to take the first step in research, right? And I think that's what Jilin's done here, is made that first step to kind of prove out the concept, and then from there someone else can work on productionalizing it. That said, because it was research, I feel like there wasn't a lot of time spent in like the documentation or making sure that the onboarding to like use the actual code was streamlined, if you will, which makes sense, right? If they're not expecting this to be used in production anywhere, and it's just like a thought experiment, if you will, it makes sense that you're going to have these problems here and there. But I just wish there would have been more print statements throughout the code to kind of show, as things were breaking, where I could go to fix them, right? Instead of having to handle that myself. Maybe I'll send a PR to them and just say, hey, I'm adding these print statements so that future developers don't run into these same problems that I ran into. Anyway, that's everything for this episode of Console. I hope you enjoyed it. I will see you next week.